As useful as OpenSSL has been for letting me manage TLS certificates for internal IT devices, after a while this becomes time-consuming and tedious. For one thing, there's a few steps to go through to create a certificate, and just before a certificate expires, you have to go through more steps to revoke the certificate and then create a new one. Now, while Let's Encrypt allows you to automate certificate provisioning, you'd need a public domain name and be willing to leak details about your internal devices to the public internet. In other words, it's a bad idea. So wouldn't it be good if you could have the security benefit of OpenSSL and the automation benefit of Let's Encrypt? Well, you can with an open source certificate authority called StepCA. Not only can you install this on an internal computer, it supports ACME provisioning. But how do you install StepCA as a container? Well, if that's something that you're interested in finding out, then stick around and watch this video, as that's what we'll be going over. Because this video is specifically about StepCA, I'm going to assume that you already have a container platform like Docker or Podman installed. If not, then I do have a video which shows you how to install Podman, which is what we'll be using in this video. Now the first thing to do is to initialize the setup of StepCA. And what we're going to be doing here is pretty much just the same whether you're using Podman or Docker. The only difference really is the actual command that gets used. So the first thing I'm going to do is to actually pull down the actual image for StepCA. So like I say, I'm using Podman, so the command is podman pull, and then we point it to the actual image. If it had been Docker, then it would have been Docker pull instead. So I'm just going to hit return, and it's going to pull down that particular image. Now, one thing I'll say about Podman is it's got some interesting cosmetic warnings, if you will. I mean, this is basically the first time I've logged in as this particular user. The idea is for Podman, I'm particularly liking the fact that I can actually run rootless containers, but it does give me this actual warning here. So this only really applies to Podman, but it's actually giving me some advice about a command I can run to remove this. So what I'm going to do is I'm just going to switch over to an account that's got sudo rights, and then I'm going to run that exact command that it's telling me to run there. So I'm going to hit return, and once my password, and that should take care of that problem in future. So in any case, we've actually got that image now. So there are different ways that you can do this, but one option is to actually run a wizard. Then it asks you a series of questions about the actual configuration. So that's just podman run. Now I'm using this --rm option here because when the actual container has finished, I want it to actually remove it. It's another feature, if you will, when it comes to Podman. It doesn't particularly like it if you try to run a container again, if that container, or at least the container name, already has been used. So even if the actual container's finished, unlike Docker, which would just repurpose it, Podman can be quite fussy. So I've got this --rm option. We want an interactive session. I'm going to point it to a volume specifically because we need to retain information if, for instance, like the host gets rebooted or the actual container gets recreated and so on. So I'm going to get it to create a volume. I'm just going to call it step-ca, and I'm going to map it to the folder /home/step. So that's to do with the actual container where it stores all its information. And then what we'll get is all that information will then get stored in the actual volume that Podman here is going to create on the actual host itself. So that gives us our persistence. And then we're actually pointing it to the image. Then we're running this command stepca in it because we want to initialize the actual setup. So I'll hit return, and as I say, it'll just go through this process of asking us a series of questions. So by default, it wants to know, well, it's asking what deployment type you want, and by default that's standalone, which is what I want. I mean, you can use the arrow keys to change that if you like, but like I say, I think it makes more sense just leave it as is and then just hit return to answer that. Then wants to know what you actually want to call this. So it's entirely up to you what you want to call it, but I'm just going to call this one HomeLab CA. It then wants to know what DNS names or IP addresses will clients use to reach this. So I'm going to reference this by the fully qualified domain name, which for me is ca.homelab.lan. It then wants to know what port do you want to bind this to. Now, I'm going to put this in here, which is :8443. As it's suggesting there, it's equivalent to 0.0.0.0 : well, in my case 8443. But the idea is this is a container. The IP address doesn't really matter. It's only got one interface, so it doesn't really matter if it listens on all interfaces, and that's what the zeros mean. So there's no point me binding this to a specific IP address, because that IP address could change. If it had been a physical computer that had multiple interfaces, that would make a lot of sense. In other words, you don't want to be listening on a management interface, only on the production interface, for example. But we're setting up a container. It's only got one interface and it really doesn't matter. But for the sake of argument, I'm going to use port 8443 just to be different from the common 443, so it's less obvious. But also because this is a non-privileged port, it's at a much higher level above the standard 1024 and above. So that makes things a bit easy if you set up containers with high port numbers. But do make sure that that port's not already in use, and you don't want a conflict anyway. So I'm just going to hit return, and then it wants to know what do you want to call the actual provisioner. Now, basically this is what you would consider to be an admin account. So I'm just going to call mine ca@homelab.lan. I'm going to give you an example there. And then it wants to know what you want to use for the actual password. So this is going to be a password that's very, very secure, that you want a really complicated password. It's going to be used by the certificate authority here for doing its signing and so on. So you do want a very complicated password. Certainly don't want one that's easy to guess. And what you've got a choice of here is to actually put in your own password, or if you just hit return, it'll create one. So I'm just going to create one, but I will give you a warning, because if we go along through here, it's using double quotes, and this is going to probably come back and bite me in the future. Ideally, you don't want to be using something that's got double quotes. So I'm going to take that out. I'm going to change it to something different, just because it's a bit easier later on. We need to actually save this password in a password file, as we'll cover. But it helps if you don't have certain characters. I know single quotes and double quotes can definitely cause issues. But again, it's entirely up to you. You can put in your own password in here if you like. But I'm just going to accept that one, hit return, and then off it goes and sets things up. Now, what I'll say is we've got a root fingerprint here, which is what you'll be using going forward to actually connect to the actual certificate authority. So make a copy of that. It's also got our password here as well. You'll want to make a copy of that. And as ever, these are extremely important bits of information. You don't want just anybody getting their hands on this. So keep them safe, keep them secure. Now, every time our certificate authority needs to sign a certificate, it needs to know what password is. And we don't want this to be an actual interactive session where we have to keep supplying that password. We want this to be fully automated. So what you can do is to set up an actual password file. To do that, what we're going to do is spin up another instance of our container here, except we're going to connect in using a shell session. Just wait for the prompt. Then what I'm going to do is to use the echo command to create our actual password file. So it's a file called password, and it's going to be looked for in the secrets folder. So basically we're just using the echo command to echo this output into that file. Now I've put it in double quotes because special characters can get in the way of the command. You can use single quotes instead if you like, but this is why I was talking earlier about this issue of checking what characters are in there, because if you've got double quotes in here, it would conflict with our double quotes. If it was single quotes, then there would cause a conflict if you're using single quotes. So that's why I've got to be a bit careful as to what actual characters end up in here. I'm just going to hit return, and it's created our actual file. But I am going to check just to make sure that that's come out correct. So it begins with a capital W and it ends in a lowercase g, so that looks fine. Now, sometimes it doesn't work. I think it just depends on what type of characters might end up in here. But if it doesn't, then the process doesn't complete. Instead of getting this prompt, you get a greater than prompt. If that's the case, well, there's two options. One is to actually use the Vi text editor, because Nano, it's not installed. So if you use Vi instead, well, that would work. The only trouble is you need to be familiar with how to actually use Vi. The alternative is just go back and rerun that setup process. It'll create a new password for you, and you can be a bit more careful in terms of what characters end up in there. But then you'll get a different fingerprint as well. So there's two ways, but most of the time I've found if you just use that echo command, that tends to be the easiest. But now that I've created our actual password file, I shall exit out, and that sets up our actual password to make this all fully automated. Now the next thing to do is some basic testing just to make sure that we can actually connect to this certificate authority. So what we're going to do is to first start up a container. I'm going to run this in the background, so just hit return and wait for the prompt. And then I'm just going to make sure that it is up and running and that it doesn't have any problems. So I'm not seeing like a restart going on here, so it does seem fine. Now, if you did run into issues, then you could just take out that -D option that'll run in the foreground, and you should get some useful information in the output. Typically what will happen if it doesn't actually start is because the password in the password file doesn't match up with the actual password that was used during the actual setup process. But in any case, this is now up and running, so I'm going to now test connectivity to this from another computer here. First thing I'm going to do is to actually download some software. And this is the Step CLI software, and then we'll then install that on this computer. And then what I'm going to do is I'm actually going to take advantage of that to actually install the actual root certificate for the actual certificate authority. Simply because the operating system here doesn't actually trust that actual certificate. So we're using steps here, Bootstrap, effectively using curl to point to our certificate authority. We're giving it the fingerprint, and this is the actual fingerprint that you'll get in the output when you actually run that initialization process, because you have to use this during that ACME process, for instance. And then we want it to actually install the actual root certificate here onto this computer, so just hit return. And then what I can do is then just actually test connectivity. So I'm just going to use curl to connect to it, and we've got an output of status OK, which is exactly what we want. The only thing is, this particular computer, the operating system now actually trusts that root CA for certificates, but typically web browsers don't. They've got their own trust store. So what you can do while we're here is to grab a copy of the actual certificate for our root CA. You can see where it's actually put it to, but I'm just going to use cat here to give me the output. And then what I can do is take a copy of this and actually install that in web browsers on computers to get them to actually trust our CA. But that's our actual initial testing done. So what I'm going to do is just come back to Podman here and actually stop the actual container. And there you go. At least we've proven that we've got connectivity to our certificate authority. Now, the main appeal of this particular certificate authority is it'll allow us to actually automate the provisioning of certificates. But in order to do that, we actually have to add a provisioner for ACME to it. And what we can do for that is to actually run our container again and actually get it to add in that provisioner so that it updates the actual configuration. So I'm just going to hit return, and we should get a positive output to actually say, yep, the config's now been updated. So what I can now do is actually spin up the container, and then it should be ready to go. So I'm just going to double check that it stays up and running. Yep, that seems fine. So our certificate authority now should be able to provide certificates to computers using ACME. The only thing to bear in mind is you'll need to make sure that those computers can actually connect to this computer on, in my case, port 8443. And also this computer will have to be able to connect to those other computers. It'll be expecting to connect on port 80, port 443, that sort of thing. And you'll need both actual computers to be able to resolve each other's FQDNs. So your actual computers that need certificates, in my case, need to connect to ca.homelab.lan, and this computer will have to be able to connect to those servers on whatever FQDNs are being involved in the actual certificate, because that's all part of the actual setup and testing process. Well, now that we've got our certificate authority up and running, we should be able to start provisioning certificates on our actual computers. But how you do that really depends on the actual client software. So let's take Proxmox VE here, for example. Well, if we connect to the actual server, go to certificates, what you would normally do to actually set this up is to register an account. So you click on Add ACME Account, and yeah, straight away we've got problems because it's only supporting Let's Encrypt. In addition, this particular computer doesn't actually trust the certificate of our actual root CA, so straight away it can't even connect to it, let alone register to it. So what we need to do is to first get this computer to actually trust the actual root certificate. So what we're going to do is just connect to the actual PVE server here, click on shell to open up a shell session, although you could just connect in through SSH. And then what I'm going to do is, just like I did on the other computer, I'm actually just going to download the actual step CLI software here, just so I can make provisioning a bit easier. So now that that's downloaded, we'll install the software, and then I'll take advantage of that to actually install the root certificate. So that's a good sign. It's been able to actually connect to the actual computer, and it's installed the actual root certificate. Now, as I was pointing out, there is a slight problem now in that at the moment, Proxmox VE here, it only allows connectivity to Let's Encrypt, or at least through the GUI. What you can do is to actually run a command to actually register an ACME account through the command line. So because this is a custom CA that we've set up, we're going to use PV node ACME account register. Then you can give it a name. By default, it's actually called default, so we'll leave it at that. Contact details, well, I'm just going to set this up as test PV at homelab.lan after the actual computer. And then we need to point it to the actual directory. In other words, tell it what to actually connect to. So it's the URL for our actual certificate authority, then /acme/acme/directory. So hit return, and we'll just wait for it to actually register. So that's a good sign. It's actually connected, and it says it's got its registration there. Now, we then run into another hurdle, if you will, in that Proxmox VE here is using port 8006, but the certificate authorities typically expect connectivity on port 443 for a web server, for instance. So what we're going to do is add in an actual rule into IP tables, which is to redirect requests to port 443 to 8006 here. Now I'm being a bit specific here in terms of connectivity, because I want to be very careful as to who I'll allow access to this server in the first place. So I'm setting the source as the IP address of the actual CA, and the destination is the IP address of the actual computer itself here. So I'll hit return. Then I'm just going to check that's taken effect by running this command here. And it shows me the actual list of rules, and we've just got that one that we've set up here. It's coming back saying the source is Docker demo, but that's just because of the first entry in DNS that I've got. But it is correct anyway, so that's fine. And then what I also need to do is to actually make sure that this actually survives a reboot. So I'm going to edit the /etc/network/interfaces file here. I'm going to scroll right to the bottom for this interface, and I'm actually going to use the post up and post down options here to make sure that that actually gets run when the computer is back up and running again. So I've got one rule to actually add that in and one rule to take it back out again. So I'll save that config file. Now we'll go back to the GUI, and then down here under system, click on certificates, and we've now got our registration. So we can now add in a domain here, so we'll click on add. Now I've got choices of HTTP and DNS. DNS is a bit more complicated, I must admit. HTTP is a much simpler strategy. I don't mind that on an internal network. It just means that the actual CA server needs to connect directly to this actual server, in which case I need to put in the fully qualified domain name for that. So this one is testpve.homelab.lan. Click on create. And then, now that that's set up, we're going to click on order certificates now just to get things started. So click that. Then it should go off and connect to the actual certificate authority. And we've just got to wait for this to actually get provisioned. And there you go, it's saying there, it's creating this the CSR, it's going through the process. So we've just got to wait for this to finish off. One thing it does is to actually restart the PVE proxy. Now, one thing to bear in mind is that even though we love getting a certificate from the actual CA, the problem is our browser here doesn't actually trust it. I mean, if I have a look at the details here, more information, there's the actual name there, and it's a case of, well, we don't trust that. So that's a bit of a problem. We don't trust the actual certificate, I should say, the actual certificate authority. I'm just looking for more details. Usually it's got some information there. Just click on the padlock there. Connection not secure, more information. Yeah, usually somewhere in here it's just saying verified, not specified. So what I'm going to do is I'm just going to go into the settings on this browser here. So this is how I set it up for Firefox. I'm going to go to privacy and security. I'm just looking for the actual certificates options. Permissions, security, view certificates. So I want to select that option. I'm going to import an actual certificate, and I'm going to point it to the actual root CA certificate that I've got. So for me, it's this file here. So just double click that. Yes, I'm going to trust it for websites. I'm not going to be using it for emails, so I'm just going to click on OK. You scroll down, just keep scrolling. That's it there for me, HomeLab CA. So I'll click on OK. I'll close that. Control F5 to refresh this. And you can see now it's actually got the padlock. In other words, my actual web browser does actually trust the root certificate authority. Because it trusts the CA, it's trusting the certificate that's been assigned to this actual server. So if I click on that padlock, usually you can get more information out of these. So there, it's verified by HomeLab CA. Click view certificate and it gives me the details. Now, things to point out is that this has been provisioned, it's getting on to about 2:45 in the afternoon on the Monday, and this is going to actually get revoked. Essentially, it's going to expire within 24 hours. That is deliberate. So normally when you're setting up manual certificates, you probably get them to last for maybe a year or so. when it comes to this particular process, because it's a fully automated process, and Proxmox VE here itself is actually going to regularly update its certificates. There's a setup in here to actually do that. The idea is that the certificate authority itself doesn't have any built-in revocation. If the actual private key and the certificate that goes with it were to get stolen, well, it's going to expire within the space of 24 hours anyway. By the time somebody gets access to that, by the time they actually try to go through that process of redirecting you to a malicious website, pretending to be that server, chances are it's probably expired anyway. So that's what they're working on, is that your certificate's going to expire before you run the risk of having to go through this revocation process anyway. So just bear in mind it only lasts 24 hours, but as long as the actual client keeps automatically updating it, then you're fine. You just don't have to touch this again. It's a one-off process where we set up the connectivity, tell it to go and order a certificate. After that, the actual client should take care of that. So in this case, we've now got our actual certificate. As I said, it's valid for 24 hours, and now I've got my browser trusting it. And it's just a case of repeating that for all your other computers that trust this ACME process. Well, we've now got a certificate authority which is supporting ACME, which means we can go out and start automating the provision of certificates for our computers. The only trouble is I'm actually running that as a container on Podman, and if the host actually reboots as is, this container isn't going to survive. It's not going to automatically come back up. Now, when I originally set up Podman, I set it up to use Compose. In other words, I've got a service account which will start actual containers up that are defined within a Compose file, but you could set them up as individual services if you like. The problem is I've actually run into issues with Podman Compose, or at least specifically with the one that I'm getting through the Debian repository. So although I do still want to continue using it, I need a newer version to fix my problem. So to do that, first thing I'm going to do is to actually remove Podman Compose. So sudo apt remove podman-compose, put in my password and just wait for that to actually get removed. And the problem I've been running into is specifically around volumes, in that if the actual volume already exists, well, for whatever reason, it just creates a new one. It just doesn't seem to be interested in following the proper process, shall we say. So for that reason, I want the newer version. To do that, I'm actually going to install pipex, which is the recommended way of actually installing third-party Python applications, at least when it comes to Debian anyway. So I need to install pipex first. I'll just wait for that to finish off. And then once it actually gets finished, we can actually then start using pipex to install a newer version of Podman Compose. Well, now that the installation is completed, we can get on with installing Podman Compose using pipex. So this time I'm back in the actual Podman user account, because when you use pipex, it's all getting done on a per user basis. So I've got to make sure that I'm in the proper account to begin with. So I'm going to run this command first, just to make sure the path's up to date. So pipex ensure path. As it says, it's best to exit out and log back in again. So I'll just switch back to its home directory. And then I'm going to get it to install Podman Compose. So pipex install podman-compose. Hit return, and now I've just got to wait for it to install this. Now the next thing to do is to edit our compose file. So I'm going to use nano to edit a file I called compose.yml. Now this container does have a volume mapping, so I need to tell it about the volume. Except, as well as actually defining the volume, step-ca, I'm also putting this line in external true, because this volume isn't being managed as such by Podman Compose was actually set up originally as part of some sort of initialization setup process that we did using the actual Podman command, so it already exists. So by putting that line in, we should be telling Podman Compose here is just leave this to be managed externally. The volume already exists. All you've got to do is take care of actually connecting it to the actual container. And we then actually need to define that container underneath our services section here. So I'm telling it what the image is. I'm giving it a name of step-ca to make it easier to identify in a command line, for instance. Telling it about the ports. I want it restarted, and that's how I'm going to manually stop it. And then we've got to put in our volume mapping. So /home/step is the folder which is internal to the container, and we're mapping it to our step.ca volume here. So save that file. We're then going to stop our container because this one's being run by Podman. Then what we're going to do is start it up using Podman Compose instead. Now, this is, I've found, to be a lot more verbose, shall we say, than Docker Compose. Normally, if I use the -d option, there's just nothing comes out at all. Whereas here, it's going through quite a bit of information. It's even telling us it's skipped the web server. It's got this one running. It tried to stop the actual container, but, well, there was no such container. It tried to remove it, but there was no such container. So it is still running in the actual background, though, because for one thing, we're back on the prompt. If I do podman ps, our container's up and running. Now, I do want to make sure that this is actually operational. So I'm on another computer, and I'm going to run curl to see if I can connect to it. So that seems fine. And it should be, really, because it's the same volume, same contents, and so on. But the thing is, I actually made a change here because the original Podman Compose was global. This version is specific to this user. So I need to edit my actual service file and tell it where to look now. So Podman itself can stay as is. That's still basically installed using the normal Debian repository, but when it comes to Podman Compose, it's no longer in /user/bin. It's in the user's home folder .local/bin. So something to bear in mind if you're using service accounts with pipex. So they're updated. I don't want the double slash there. So first thing it should do is a system prune. Then it'll run Podman Compose using that YAML file. And then if it stops, it should shut it all down. So we'll save that file. Now, we've made a change here. So what I need to do is just update the daemon there. And then if we do sudo systemctl stop podman-compose, it doesn't seem to want to have this out for some strange reason. Okay. So I'll then start it back up again. So it's taking a bit of a while because it's got to go through this prune process. But then once it actually finishes, we'll then be able to check and just make sure that it actually does come back up, because I need to make sure that this survives a reboot. Reason being is that we've now got a certificate authority that we actually want running 24/7, because these certificates only last for 24 hours basically. So let's just check the status of that. Okay, so that seems okay. So we'll go back to the user account, podman ps. So they're both up. And if we go back to our actual external computer and just see if we can connect to it, that seems fine. Now I'm going to just double check and have a list of any volumes we've got. So we've only got one volume, so that's a good sign. The reason I'm checking that is just, like I said, with an earlier version of Podman Compose I was getting from the Debian repository, I was ending up with multiple versions of the actual volume. I had that one created from the podman command, and then podman-compose was creating its own. But from what we can see now, the actual service is now updated, and it's going to be using this podman-compose that we got through pipex going forward. But it means I can now go out to all my other computers that support this ACME provisioning process and get them to connect into this certificate authority, and that should make life a whole lot easier. But the actual CA that we've got, it does also support manual provisioning of certificates as well, because there are some actual systems out there that just don't support ACME. Now, I must admit this was a bit fiddly to set up using Podman. It should be easy to do on a default installation of Docker though, but I prefer the security of rootless containers. Do bear in mind that servers using non-standard ports add a bit more complexity to the ACME process, because this is geared towards web servers using port 443. But once this is all set up, your servers should keep their certificates up to date on their own. Now, not all devices support ACME provisioning, for instance, network devices. Unfortunately, this CA does support manual provisioning as well. So, in the grand scheme of things, I expect this CA to save a lot of time going forwards. Now, if you find this video to be useful, then do consider subscribing to the channel, as that would really mean a lot to me. But it's also a good indicator to let me know how videos like this are helpful to people such as yourselves that are watching. In which case, thank you. On the other hand, if you're not ready for that level of commitment, then I'd really appreciate it if you could press the like button, because that way that'll help to get the video out to other people that might find it useful as well.